All right, this is our last lesson on section 8.4. So this is 8.4C. The same essential standard. I can create histograms and box plots, which we have learned how to do, both of those. And we can describe and compare distributions in context from either a histogram or a box plot with appropriate summary statistics. So yesterday we did histograms and we learned how to describe them. And today we're going to describe in context box plots, okay? So even though 5-number summaries cannot fully describe the shape of a distribution, in other words, it's hard to see if there's a gap in the distribution, for example. The box and whisker plots that are based on those 5-number summaries are very commonly used, and they usually do a decent job to describe the distributions of univariate data. We're going to describe 3 things again. We're going to describe shape, center, and spread. The shape of the distribution can be determined by examining the tails and the box in the middle. So let's go take a look at the shape of a symmetric box and whisker plot. So I'm looking at the symmetric, and what you can see is that let's use a different color. The amount of the size of the box to the left and to the right of the median is about the same. Okay. In addition to that, the length of the tail to the right and the length of the tail to the left are about the same. And that is what makes that symmetric, as opposed to, or in contrast to, one that's positively skewed to the right. So the box to the right of the median is larger than the box to the left of the median. In addition, the tail to the right is larger than the tail to the left. Okay, and that would mean it's skewed right. Skewed left or negatively skewed, the box to the left of the median is larger than the box to the right of the median, and the tail is also larger than the tail. Okay, so that's how we can use the box plot to describe the shape of the distribution. Okay, the center, when we describe the center, we will describe what the median value is. Okay, we don't have the mean in this situation. And then the spread, which has to do with the variability, we will often use the range. So we'll have the minimum and the maximum, okay, and or the IQR. So the min-max has 100% of the data, and the IQR, the inner quartiles, are the inner 50% of the data, okay? All right, so those are how we will use our box and whisker plots to describe shape, center, and spread. So let's go ahead and take and see how this is done. So let's take this data. I would pause my video if I were you, and I would enter into list 1 the data for wages in the table to the right. The hourly wages for a random sample of employees of a restaurant are shown in the table to the right. Using a graphing calculator to create a box and whisker plot, use this graphical display to describe the distribution in context using appropriate numerical summary. So go ahead and pause. And okay, now that we have our data in our list 1, we will go to second function. We're going to make a stat plot again. So we will hit second function, and we'll have hit y equals, because we want that statistical plot. And we will go and select the first plot, so plot 1, and hit enter. And we will make sure that it is on, that we have selected the box and whisker plot. We like our first option. Makes those lines a little bit easier to see if I understood him correctly. Make sure that your list is correct based on which one. Frequency is going to be 1. We like the larger mark. And once we've had all of that entered, we will go to zoom. So we will select zoom right here and select number 9, which is zoom statistics, which makes our window nice. And once we do that, we will see this graph right here. Now, if I am in this screen, at this point right here, all I have to do is hit trace So that would be this button over here. The one to the left of the graph up top, trace, and that will allow me to move my cursor from points within this box plot and get the values from each one of those locations. Okay, you do not have to go to stats, calculate one variable statistics to get all of my min max. Those are only here for the purposes of helping me make my video, but you can use trace in this window to find your actual values, if that makes sense. Okay, all right, so here's how we will then describe our distribution. The distribution, actually, let's go ahead and talk about what you see over here. Sorry. Notice that I have a larger box to the right and my tail is larger to the right. So I am skewed to the right, correct? Okay, so we will say the distribution of what? What are we looking at? Well, we have of hourly wages for a random sample of employees of a restaurant. So the distribution of hourly wages for a random sample of employees of a restaurant. So now I've described exactly what we're talking about. Is, well, is it symmetrical or roughly symmetrical, skewed? Well, we know that it is skewed positive or right. So we'll say to the right. All right, there's the shape. We have discussed the shape. Now we need to discuss the center. So the median, okay, median hourly wage. So we would go and hit trace and cursor over to that center, and we would find that hourly wage, the median hourly wage is $7, and I'll round it to cents, is $7.88. Now we need to talk about range. I'm sorry, spread, excuse me, that was the term, spread. And in this case, we need to use our min max and our Q1 and Q3. So all hourly wages are between, so here's my min max. So I'd go to and look at this, sorry, I would use my trace and I'd go find that value and that value are between 6.5 and $11.25. The middle 50%, that's my Q1 and Q3, the middle 50% of hourly wages are from, and I would take my trace button and go find this value and this value, which are $7.25 to $9. And there you go. So we have described exactly what we're talking about, hourly wages, the distribution of those wages. We have given the shape, which is skewed right. We have given this center, which means the median, and we have given the range, I'm sorry, the spread. And in this case, we had to use both the min max and our interquartile range, okay? All right, let's do another one. Now, often there are two or more distributions, and it is desirable to make a comparison of the two. So this is kind of fun. So box and whisker plots work exceptionally well for comparisons when they are drawn side by side. Now, be careful when you compare your data. Students often analyze each box plot individually, but never compare. To compare, you must use comparative words such as greater, lesser, or the same. In a comparison, So this is even, so the green is super important, and the next one is important. In a comparison, the exact values are not important. The comparison is what is important, okay? All right, so let's get ready. We're gonna go ahead and talk about how to do that. So we have Robert, he recorded his golf scores for his sophomore and junior seasons. This data is shown in the two tables below. Construct side-by-side box plots of the data sets on your graphical calculator. And we're going to compare the two distributions in context. Make sure to address the three things: shape, center, and spread in context. All right, this is what you're going to do. You're going to go and pause the video. You're going to take this data set. Please do this. And you're going to enter that into list 1. You are going to then take his junior data set and you're going to enter that into L2. So pause your video and go ahead and get that done. Okay, so now that you have the sophomore season in list 1 and the junior season in list 2, it doesn't matter what order, by the way, when you're entering this into L1, it'll take care of itself. And same with the junior season in L2. We're now going to go to, second function stat plot so that we can create some stat plots. We are going to go and we're going to go to turn 1 on and we're going to turn 2 on. And notice we will have L1 plot 1 be from L1 and plot 2 be from L2. They are box and whisker plots with frequency 1. Don't change the frequency. When you are in this plot 2 and you need to select list 2, how you will do that is you will go to where it says, it will probably show L1, you'll be on top of that, and then you will hit second function, right? You will hit second function and you'll go find that L2 is above the numerator 2. So you'd hit second function 2, and that will change that L1 to L2, by the way, okay? And then you'll hit enter, and now we've got both our plots turned on for L1 and L2. Plot 1 is L1, plot 2 is from list 2, and we will then go to, with any statistical plots, we will though go and use zoom, okay? We'll go to the zoom and we'll hit zoom stats, which is now option 9. And now we will see this graph right here. Now I will use the trace button, which is up here, and that will allow me to move between the two box and whisker plots. So if I forget which one is which, this is L1. Let me use the same color. This was L1 and this is L2. Which gives me, again, the ability to not only get actual values, it actually gives me the ability to remember which one is which, okay? Or not to figure out which one is which. Now, we don't actually need actual values because we're doing a comparison. And so, as you can see, in comparison, the exact values are not important. The comparison is what is important. All right, so let's discuss. Now we see what this looks like. So we are going to compare the shape, the center, and the spread in context. So the distribution, that's what we have here. We're comparing the shape of the distribution. We're comparing the center. The distributions of Robert's golf scores. Okay, actually, before we get into that, let's take a look at the shape. That's what we're talking about. Notice that I have about the same size box on each side of the median and tail on each side of for list 1, which is a sophomore season. In addition to that, I have exactly the same scenario. I have essentially approximately the same size box to the right and left of the median and tail to the left and right of median. For his sophomore and freshman year. So roughly both his sophomore and junior year were symmetrical. Okay, so the distribution of Robert's golf scores for his sophomore and junior year are both roughly symmetrical or symmetric. We have discussed we have compared the shape between the two. Now, what if one wasn't? What if L2, which is junior year, was skewed right? Okay, so the word both is a comparative term, so we want to use comparative terms, right? So let's pretend that it was skewed. So we would say the distribution of Robert Goff scores for his sophomore year was roughly symmetrical. However, his junior year was skewed right. Okay, so somehow you would have to describe both of the distributions compared to each other. Okay, all right, next, that was the shape. Now we need to discuss the median and compare it to one another. So notice the median of his sophomore year is larger than the median of his junior year. So we would say the median Goff score is less for his junior year or his junior season than the median for his sophomore year, which is a good trend. So he was getting better. Season. Okay. So we have compared the two. We have used comparative terms, less than, greater than, or the same. All right, now we need to talk about the spread. So if you can tell, based on the min max and also the Q1 and Q2 values, that the spread in his sophomore season was larger. So that means his variability was larger, okay? In addition to that, his junior year was had less variability. So we could say something about Robert's Goff scores for his sophomore year are more variable than junior year. Now, there's more than one way to have evidence of whether or not his variability increased or decreased. So it's kind of nice to give a reason why you feel that way. So we will say, as evidence, by the larger, so what do we use? We use the range and the IQR for his sophomore distribution. Okay, so we were really clear in that sense. So we have discussed the shape, we have discussed the center compared to each other, and we have also discussed the variability or spread. And in this case, we used the range and IQRs and said that there's more variability in his sophomore year than there was his junior year. All right, I hope that makes sense, and I will see you in the next video.